Okay, in this little video we're gonna hook up the little potentiometer. What is a potentiometer? Is a turning knob that can turn from 0 to all the way open. How does it work? You have 3 little pins, and the first pin is basically connected to the last pin. The second one has a dial, and this dial just slips a little piece of metal over this connection, which means normally some power can run through, but if you connect a pin up till the middle, based on where it is, it will have more or less resistance. So if the dial is all the way over here, then the power comes in and basically just hits the dial right at the start. So this means there's almost no resistance happening on the power that runs through. Now, if it's all the way open, like for example where it is now, that means that the power running through has had resistance all the way up till here, which means that it loses about 80% of the power. And we can measure this in our little Raspberry Pico. So in this way, if it slips over, then you know how much, you can measure how much resistance it has encountered along the way. And by measuring this resistance, you know how much it is open. On the little potentiometer, there is a number, 10K, which means from here to here, there is about 10K resistance. There are way higher ones, and sometimes if you take the wrong one, it can cause your circuit to be completely amiss, because then the resistance is too high, even if you open up a little bit for the Raspberry Pico to measure. How will we hook this up? Basically plug it in our breadboard, and the first one over here we can turn to power up. So again, we use the rails, the positive and the negative rail. And the last one, or the top one, we can use ground. Does it matter in which direction you put these, whether you flip them around or not? Well, not entirely. That just means that you put plus here, for example, and minus here, which means that if your potentiometer is all the way open, that means you will have the least resistance. So your numbers will just be inverted, but that's not really an issue. It's easy to fix that in the code. So what we are going to do is to write this code, and we will use, instead of the PWM, but you can just leave it, ADC, analog to digital conversion, which means it can take an analog signal, a voltage that comes in, and it will convert it to a digital signal, something that your Raspberry Pico can understand and can work with. So we will import that. It's also part of the machine library, and we can start making a variable for this one as well. For example, potentiometer equals ADC, same as in pin. Which pin? Well, that's a bit more special. What we need now is a pin that can actually understand these functions and understand these kinds of signals. And that is on our sheet noted with ADC. So we've got a few of them. For example, here, we've got one here and here. And I thought we had some other ones, but that's about it. So we got 3 pins in total who can manage an analog signal, which doesn't seem a lot, but most of the time is very well enough. So we have this hooked up, and now we can go see which one we need. For example, the first one here, pin 28, has this function. It's 2 separated from the 3 volts, so I can just plug it in there and hook it up to the middle, this pin of the potentiometer. So this one is now connected to pin 28. Feel free to keep these kinds of little schematics for yourself in a little notebook or anywhere else, so that you know always which pin is connected to what. Once we've done this, we can now start and check out our loop, basically. What do we want to do each loop? And we can start by adding a little value to work with, because it's a very specific line of code that we can use, which is basically, we went from the potentiometer to read U16. Why is that read U16 instead of something easier? It's basically because this is the resolution with which we want to read it. So this means that we have a float integer of a certain size. That's why this ends up at 65,000 because the amount of bits that it is using up. But that's not important. It's always the same. Once you're reading a potentiometer or some other sensor, just use this piece of code and it will be fine. So now that we have done this, we can print it out. And we can print just the potential value. What we do want to do as well, and that's just for our own thinking or our own processing, is that we add a little sleep value, a value that just says, all right, sleep every half a second, just to make sure that we are not overflowing with all this information. I forgot to add this little 28, our pin, and it says it's right here. Function takes one position argument, but we're given 0 at line 6. So that's here. It's the one argument it was missing. So if I run this, you can see the numbers coming in. Now if I turn it, now it's all the way closed. It's starting at 272. So that's about the lowest we can go. Sometimes it's a bit iffy, but that's where we end up. If I turn this all the way open, we're ending up at 56,000. 56, yeah. And in the middle, it's somewhere in the middle. So this is a value we can work with. So for example, if I now say I want this to be, sorry, I cannot click there. I want this to be divided by 56,000, and I run it again, then we have a number between 0 and 1, right? So this is something easier to work with. Now what can happen as well is that we say, and now I'm just messing around a little bit, is, for example, we can start using this information to turn on our little LED. So if I take an LED, and for funs and giggles, I will take the RGB LED for a second. You will see why in an instant. And I plug this in. This also has a long leg. You keep in track of which one is the longest leg. Up, I can plug this one in, all four in their own separate column. Again, we will need this little resistor, and I can add this resistor in the middle of the ground. I think this is a common cathode one, which varies basically which one is the positive. I will try this out with you, because I don't know for sure, and that means that I have to test things out. But it's useful for you to see as well how I test these things out. It's always a bit iffy to get these in because it's 4 legs at the same time. For example, I can start by first putting a plus through the resistor on the middle leg, the longest leg. Why? Because now I can check, okay, what if I connect one of the other legs towards the ground? And if my LED turns on, something happens. That is very good. That means that we always use just one resistor on the middle, on the longest leg. I'm going to draw a little schematic here. So we've got our little LED, and it has 4 legs, one shorter and one longer. This is the plus. This is where our power comes in. This is the red, the green, and the blue. So that means that we can create an entire spectrum of light with just one LED. You can use the pulse width modulation, the PWM, sorry, of the last course to dim the lights as well, which is very much fun. But right now we will just use it with a pin and just use the blue one. So what I want to do, for example, is say, okay, it's very easy. If my potential value, pot value, is larger than 0.5, I want this LED to be on, which is value 1. You will see in a second that there is a little extra step that we need to do. But first, let's say which pin it is. Pin, and that will be pin 15, because we have put it in the bottom, and it will be an output pin dot out. So if I run it now, it means that it's off. When I do it all the way open, it should go on, but it's not doing it. Why is that? Because I have been using pin 15. Let's put it the other way around as well. else LD dot value 0. Is that not working? No, that is not working. Why is that not working? What if we just... That is disappointing. Ah, yes, I'm using the potential value, which will never be below 0.5. This value will be. And that is a code in the, that is an error in the code. In order, always first check your code, then continue checking your schematic. But, there we go. So if I go below half or above half, then my LED will turn off. If I go below, my LED will turn on. That might be a bit confusing because my code says that it should be off when I'm below 0.5. What is happening is because we have the longest one to be a plus, then we need this to be a minus, right? We need a ground, otherwise our current cannot flow through and cannot go anywhere. This will only be a ground when we turn our pin off. If we turn it on, it's a plus, which means we have an incomplete circuit, which means that the power will not flow. It's going plus via both sides. So this is a bit confusing, but that is basically also why I'm making these videos, to explain it to you very much in detail. But keep that in mind. Now I can say, all right, if I turn it all the way off, then that is happening. What I can do now as well is I can basically make this the PWM, but I will keep that as a challenge for you to try. If you don't manage, then let me know or come to me during class. What you will need to do is you will need to define this as a PWM pin. You will need to define your frequency, and then instead of setting 1 or 0, you can basically just say, all right, just read out the value without this, and just send that to the potential, to the PWM value, the, as you can recall, the payload. It's not a payload, it's the duty cycle of the LEDs, or the PWM LEDs. That might be vague, but try it out. Try and see if you can figure it out, and let me know if it doesn't work out that way.